Hey everyone, so I have here a sample of 8 pieces of data. I'm going to say that these are our test scores for a class. I've got 8 students in here. We've already taken a look at how you find the median. The median in this case, capital M, looks like it's 81. It's halfway in between. All right, the average, or we use x bar to be the average or the mean. I would add all of these things together, which when I add them up equals 640, and I divide by how many of them I have. So I divide that by 8. So I end up with 80 as my average. Now I want to remind you what we're really doing in that average. We can see it sometimes written like this. We're taking the sum of I from I equals 1 all the way up to n, like how many of these things we have, and we're dividing that by the number. All right, so that's why I'm saying we're taking the first one, the second one, the third one. That's all our xi's. We're adding them all together, and we're dividing it by how many of these things we have in 8. So that's the average. You know, most people just say you add them together, you divide by how many. But that's the average. We're going to take a look today at something called the standard deviation. And when we take a look at the standard deviation, it starts with something that's referred to as variance. And we're going to use the Greek letter. It looks, I always thought this was an R, but it's the Greek letter sigma is what we typically use, or S, S squared. So we are going to take a look at variance. And variance really says, for all of this data that I have up here, it really says how far is each point from the mean. From the average. All right, so how far is that? So that's what we're taking a look at for variance. So let's see how the book shows, or how the formula for variance. We'll talk a little bit about then how to find it. We're not going to do this by hand very often, in fact at all, because it's just a really convoluted, kind of complicated way of doing this. So first thing I do is I figure out how far is each point from that. And then I'm going to be looking, I should have finished this before, so I'll jump down here. How far is the average of how far is each point from there? So let's take a look. I'm going to first of all do some thinking about distance. Distance is always subtracting, so I'm always taking these points and I'm going to subtract 56 from 80. Let's do it that way. I could do it either way, you'll see in the end, but I'm going to do it 80 minus 56. I'm going to do 80 minus 67. I'm going to do 80 minus 78. What I'm really doing for each one of these is I'm taking the average minus the number, or as they would show over here, the average minus each individual item, like we had over here. So really, I'm just 80 minus all these. So 80 minus 56, I end up with 24 and 13 and 12. Oh, excuse me, not 12. No wonder. And 2 and 0, and 80 minus 82 is negative 2. Negative 11, negative 11, negative 15. Now, we're talking about distance here, so it doesn't really matter that it's positive or negative. But we are going to then take each of those. So this part right here, this was my x bar minus xi. That's all of the data. Now I'm going to take each one of those and I'm going to square it. So I end up with 576, 169, 4, 0. This is why it doesn't matter if it's negative, because I end up making it positive when I go through here. And that's each one squared. So when you look at the measure for this, they talk about the standard deviation based on the variance. They talk about the variance being really, and I'll write it a little bit different, the sum of all of these numbers, xi minus x bar, or as the way I wrote it, and this is why it doesn't matter, I wrote it x bar minus xi, so I'm just going to keep it that way. I like to at least keep it how I have. Remember, it doesn't matter because you're going to square it. I'm going to take the sum of all of those things squared. All right. Then they show this a little bit different, but I'm going to divide it by n minus 1. Now, a lot of people are going to say, well, wait a second. If it's the average, why are we dividing it by n minus 1? And that has a lot to do with what's called a biased or unbiased kind of variance or sample that we're measuring here. So we're doing n minus 1 because we could have some errors in the sample. Remember, a sample is not the entire population of things I'm measuring. So if I wanted to see, how many cars do the people or students at WLC own, I'm not going to interview everybody, but I might just take a small sample. But I use this because it'll give me a larger standard deviation, and that'll start to make sense when we start seeing how this data looks out here, what the standard deviations really are talking about. So that's the first step, is to take all of these, to add them all together. Now that I've squared them, this is me adding them all together. So in this case, and I'm just going to pause it and add those up. I don't know what it is off the top of my head. All right, so in this case, taking the sum of all of these things, and a lot of times people should really say this is from I equals 1 to n, but they just leave that out. This just means the sum for all of those. The sum is equal to 1,220. All right. Now, that last step to find the variance, I'm going to divide that by n minus 1. Well, remember, I had 8. That's how many things I have. So I'm going to divide this by 7. It's going to be a little bit larger than the average, but that helps me account for kind of that bias. So 1,220 divided by 7 gives me 174.3 when I round that off. All right, so 174.3. Now, the standard deviation is just S. So I'll use either one of those. The standard deviation, I really take the square root of the sum of all of these things divided by n minus 1. So that's the formula that they have for the standard deviation. So I'm just taking the square root of that. 174.3 divided by, or excuse me, square root. So I have a standard deviation of about 13.2. So what does that mean when I have a standard deviation of 13.2? So let me take these things and throw them onto another page here and talk about that. So a standard deviation, we've probably seen many times this idea of data falling inside of what's known as the standard bell curve. All right, in this data, we've got 80 right here. The standard deviation is going to be these marks that start to show up that kind of divide this in. Most of the data in this one, I said it was 13.2 was the standard deviation. That means from here to here is 13.2, and the same going the other way. So it gives me kind of a number that I can throw on here and say 93.2, and on the other side, when I subtract it, the 80 minus 13.2, I have like 67.8, but I'm double checking myself. 66.8. Man, I keep forgetting to carry things here. So 66.8. All right. So what that tells me is that the majority of the people in this standard kind of set, the majority of the people are going to have scores between these two. All right. It's the next one, I would go another 13.2 over. 66.8 minus 13.2, I'd end up with like 53.6. That's the second standard deviation. And then there's actually one other standard deviation, and this is where you start to get, the people that are really far on either side. So we'll talk about this and how much of the percentage is in each one of those a little bit later. But that's how we use standard deviation. It's really for this bell curve to see, this is where we expect most of the data to be, between 67 and 93. And if you look at that, look at this. All of the data that's between there, right there. All right. we have one piece of data on each of the other ones that's outside of it. Now, the more data we have, you're going to have more than one or two, but it shows you where the majority of people are going to be. So when you've heard things about people grading on a curve, that's what they've really been talking about. So there's an example. I would encourage you taking a look at the example in your text on page 50 and maybe just trying to walk through their example with you. But the idea is to find the standard deviation, you are going to take the sum of each number subtracted from the average. All right, that's what this means. Add up, take all the numbers, subtract them from the average, and square them. Then add them all up. Then divide it by n minus 1. Now there is something that's, you will see this from time to time when people are talking about finding s or that sigma. There is another method for doing this that's called a biased sample or a biased variance that doesn't have the minus 1, but we want to, as you'll see in the book, we want to use that. So we want the square root of all of this to be our standard deviation. And that helps us see how far away from that average. So it goes hand in hand with it. Work through some of this. Like I said, we're not going to do a lot of this by hand. In one of the next videos, I'm going to show you how to use software to do that. You could probably find it very quickly as a formula in Excel. A little bit nicer than having to use a graphing calculator because that requires a lot of entry. But make sure you're familiar with using them on Google and whatnot. But we want to understand what that means about the data. So that's our true goal.